For this section of the tutorial, we will go over how to update our date-time data and also how to plot a little bit more complicated date-time data plots. First of all, we want to update our date-time data. Well, if we want to do that, then we can use the function update like so. Note that for this function, since we are not creating a new date-time data, we would need an argument that specifies a currently existed date-time data, and that's why dt is right there. Also note how update automatically adjusts this output to May 1st because it recognizes that April 31st does not exist when we try to set date to 31 when we're updating our dt data like so. So far we have learned how to plot graphs with date data types such as month, like the bar graph, in the x-axis. But what if we want to plot our time data in the x-axis instead? Although it sounds simple, plotting time data may be a bit harder than it seems because there is actually no function in the lubridate package that allows us only to retain time data. So in other words, there's no HMS function in lubridate. So to loophole around this issue, we can use update. And basically we want to update all dates in our data to the same date. Let's just say January 1st, 2015. So that when we plot the graph will be representative of friends' visits in each hour. So basically what we're trying to do is we're trying to trick R into thinking that all of the rows, all of our records are the same date. So what only matters is the year. It'll make more sense when we start plotting the graph. So let's check the dataset again before we start plotting. Recall that in this dataset, we have already converted the visit time column to contain data in the date time form. However, right now, R recognizes this column using date and time. But we only want R to distinguish the different times of our graph, not the date. So as we've discussed before, we want to trick R into thinking that all 365 records are of the same date, just different times. And to do this, we can use update, like so. So now if we look at the new visit hour column, all records should have the same date, or 2015-01-01. Perfect. So the next step is to actually plot this on a frequency polygon, like so. And this graph is a bit tricky to read because even though the x-axis says that all data points are within January 01 or January 1st, we know that this is not true. We know that the data displayed are from January 1st to December 31st because we explored the dataset before. And again, the reason why our x-axis is labeled as January 1st is because we have tricked R into thinking that all data points are of the same date, so that our graph can plot the number of friends' visits depending on times. So now let's think about what information we can conclude from the graph above. What about around what time frame do our hosts receive the most friends visit? Also note that each bin width, for example, bin width is equal to 1, is equal to 1 second. So bin width equals to 3600 means that we are clumping all visits within 60 minutes, aka 1 hour, together into one single data point in our frequency polygon. And if you still don't understand what bin width is, it is recommended that you go back to tutorial 5 where we cover ggplot. If we don't want to trick R, then there is actually an HMS function, but it doesn't reside in the lubridate package that we're using. So this HMS function will make our life much easier if we want to plot just the time, because it retains just the time. It doesn't really care about the date. So to use the HMS function, you need to first download and attach the HMS package like so. And then if we keep all of our codes similar to the one we wrote earlier, except change update to HMS, then you should get the same frequency polygon as before, given that we changed the bin width to match. Yeah. And also in this specific graph, the x-axis is also correct because it only has information on time. Next is arithmetic operators with date time. So you can explore this on your own. It's quite easy and it's very straightforward as well. But we can use all the other functions that we've learned before, and we're free to add hours or days or minutes to our current date time data. It's relatively straightforward. The part that I want to go over is this part right here. How do we account for leap years and daylight savings? Well, there are actually very specific functions that consider leap years and daylight savings. And the only difference is that the function that considers leap years and daylight savings have an extra d in front of them. Okay, now for example, if we compare the outputs of these two functions, you will see that there is a 1-day difference between the two of them because there is the extra day in the leap year. And then also for these two outputs, the second one is the days instead of days, and it accounts for daylight savings, so it adds an extra hour. And this is relatively straightforward, but you're free to play around with it, and maybe you'll see some very interesting things. After completing this tutorial, you should be more familiar with the lubridate package and know the basic ways to deal with datetime data in R. This tutorial covered how to create datetime data, how to retrieve information from existing datetime data, as well as how to modify and plot datetime data. And also how to conduct simple arithmetic operators using datetime data. Datetime data is quite interesting once you get the hang of it. And this data type can give us very valuable information about the data set that we're working with. Again, it's okay to make mistakes and be confused when we first got started, but know that fluency also comes from practice. And that is a gentle reminder for you to try it yourself sections as well as the Google quiz. Good luck!